All right, part two here. We're going to keep going through some examples. And again, you guys can fast forward if you need to, or pause it if you need to, but I'm just going to kind of reiterate some of the things that's already been said and just try to, push home some of the important parts. First thing that I would suggest you guys do is anytime you guys are given an equation, I would suggest that you guys write your or label your A, B, and C values. Right? I think it's just a good starting point because you're going to do that for a lot of other things. All right, so your A value in this case is 1. It's a shy guy. Your B value is -4. Don't forget to include the signs. And your C value is -5. Again, that's why you have to put it in standard form, ax squared plus bx plus c. Once you guys have that, you plug in your values and you simplify it down. You plug them into your axis of symmetry, and then you come up with your value. In this case, x equals 2. And that axis of symmetry is this dotted line that was drawn that splits this parabola in half. So what you can do is you can start by drawing this dotted line. Think about that, it's like a mirror that you're putting down because it's going to be a reflection on either side of it. It's going to match it. And then you're going to find the next thing you're going to do is you're going to find the y value of your vertex. Again, your axis of symmetry, you use this equation, x equals -b over 2a, which you guys should also have written down. When I make a table, I usually put that number in the middle of my table, the x value. And then to figure out the y value, I start plugging those numbers in. Again, y equals, in this case, we're going to put 2 in for x, -4 times 2 minus 5. Right? So this is the work that's being done, 4 minus 8 minus 5, which is what we have here. Okay? And then when you simplify that down, you end up with -9. So you put that x value and that y value together, and that is your vertex. So now you got a point where the graph is either going to go up or it's going to go down, depending on whether this graph opens up or opens down. In this case, you know that the A value is positive, so you know that this is going to be a smiley face. So this is a graph that's going to open up. And if it opens up, by the way, that means that this has a minimum. Okay, the minimum is the lowest point on the graph. So the minimum value of this graph would be -9, or y equals -9. And that would be your minimum. Okay, a maximum would be the highest point, and again, it would be the y value of your vertex. And then after that, what I do is I'm going to figure out some points that are either above it or below that x value of my vertex, and then it's going to be reflected, right? So 0, 1, 1, 0, and then -1. No, I'm not out of room there. But what's going to happen is that if I find out that if x is 3 and the y value is -8, that means if x is 1, the y value is also -8. There's a reflection here. This point and this point match each other. Okay, if the x value is 4, which is 2 above the vertex or the axis of symmetry, then if I go 2 below that, that should have the same y value, which was -5. So if this is -5, this is -5. This has a y value of -5. This is going to have a y value at -5. Okay. And then one more. All right. So if we go x is 5, y is 0, that means if we go x is -1, y is going to be 0 there. Okay. Boom. 0, 0. All right. In this problem, there are 2 x-intercepts. Okay. So these right here are our x-intercepts. Okay, remember we can also call those roots. We can also call those solutions. Can you think of a case where there'd only be one x-intercept? What would that graph kind of look like? Well, that would be some kind of graph that goes and just touches the x-axis and then changes direction. Okay, whether it's got a negative a value or whether it's got a positive a value, there's one x-intercept there. Okay, what about a graph that has none? What could happen? That just means it's a graph that never crosses the x-axis. It can cross the y-axis, but it will never cross the x-axis. Okay, like that. So there's an example there for you guys. All right, just another example real quick. Label your a, b, and c's. Make sure that your equation's in slope-intercept form. Okay, this one has an a value of -1, a b value of 4, and a c value of 1. You put it into the formula for your axis of symmetry, and you get your x value. Once you get your x value, then you're going to plug that number back into the equation for x, and you're going to solve. That's 2 squared, which is 4, and then it becomes negative. So then it becomes -4. And 4 times 2 is 8 plus 1. Right? Add all this up and you get 5. So you know that you've got your x and y value of your vertex. You know that this is going to be opening down. And the reason we know it's going to open down is because our a value is negative, frowny face. Okay. And then you guys can, find more points from there as well. All right. Just going to keep plugging along to show you guys some other examples here. Okay, what if there's no b value? Well, that's okay. You know what it actually does? It makes the problem really easy. So if there is no b value, then what you're going to do is you're going to still label your a, b, and c values, but don't mess it up when you're doing that. And that's what tends to happen to some people. They tend to mess up where they're putting what they label as the a, b, and c. So in this case, the a value is 2. The b value is, there's no x to the first power, so that means that it's 0, and the c value is -2. And when I plug in those numbers here for my axis of symmetry, x is equal to -b over 2a, we've got -0 over 2 times 2. Oh, it doesn't really matter because guess what? 0 over anything is going to equal 0. Okay, 0 on top is okay. That just means your answer is going to equal 0. So if my my axis of symmetry is 0, that is the y-axis. Okay, so it comes down right down here, down the y-axis, my axis of symmetry. Okay, now the y value of my vertex, if I plug 0 back in here, well, that's just 0 squared times 2, that's just 0. And then 0 minus 2 gives me the -2. Okay, so my x and y values for my vertex, we know that this is going to open up because it has an a value that is positive. Okay, and then we can figure out some other x values. All right, and again, you just pick some x values that are above it. You can pick some x values that are below it if you'd like. But you don't need to find all 6 of these points out. You find 3 of them, and then there's that reflection over this to find the rest of them. Okay, so again, think smarter, not harder. All right.
Can I go in the front yard and try to catch a butterfly? Like sit in the backyard?
Yeah, not yet.
Look it up.
Say hi, Bruce.
Who is he?
Say hi.
Hi.
Okay.